Why does mass curve space-time? Because that is what Einstein's equations say. Why are Einstein's equations true? You reach bedrock. And the bedrock is, this is what we observe. These are the patterns. We describe them. But we cannot explain them in terms of something more familiar, because this is the foundation. We can explain it in terms of moving charges and quantum spin. We can write equations. We can make predictions. But if you ask why moving charges create magnetic fields, the deepest honest answer is that is one of the fundamental patterns of nature. We do not have a simpler explanation. Now this might sound unsatisfying. You came here wanting to know why magnets attract, and I am telling you that at some level we do not know why. But let me say this, that is not a failure, that is honesty. And it is also thrilling, because it means you have touched something fundamental. You have reached down to the foundations of the universe and put your finger on one of the basic rules. That is not nothing, that is everything. Let me address a common misconception. Some people think that if you cannot explain something in everyday terms, it means you do not understand it. They want me to say the magnetic force is like a stretchy rubber band, or like two people pulling on a rope, or like water flowing downhill, something from ordinary experience. But here is the problem. The magnet is not like those things. The magnetic force has no analogy in your everyday life that is exactly right. When you try to force an analogy, you end up misleading yourself. The magnetic force acts at a distance, through empty space, without anything touching, and the direction of the force is perpendicular to the motion. What in your kitchen behaves like that? Nothing. So, the honest thing to do is to let the magnet be itself. Accept that it is a new kind of phenomenon with its own rules. Learn those rules. Get comfortable with them. And after a while, magnetic forces will feel just as intuitive as rubber bands, because you will have built new intuition. Experiment. Imagine you could shrink down, way, way down, smaller than a cell, smaller than a molecule. You are now the size of an atom floating inside a piece of iron. What do you see? You see a nucleus at the center, heavy, made of protons and neutrons. Around it, electrons, not orbiting in neat little circles like planets. No, quantum mechanics tells us they exist in clouds, in probability distributions, in fuzzy regions of space where they might be found. And each of these electrons has its spin, this intrinsic angular momentum, this tiny magnetic moment pointing in some direction. Now look around at the neighboring atoms. You notice something peculiar. The spins of the electrons